Hello, everyone, and welcome to Building with AI in Kotlin. My name is Márton Braun. I'm a developer advocate at JetBrains.
Yep, and hi, my name is Sebastian Aigner, and I'm also a developer advocate for Kotlin at JetBrains.
This talk will explore Kotlin and AI in two parts. In part one, we'll see how AI can help you write Kotlin code for any application. And then in part two, we'll look at building AI-powered applications in Kotlin using the Koog agentic framework from JetBrains. We know that people have a wide range of preferences when it comes to AI tooling. Some people want minimal help. Some people want AI to do all the work for them. And we have you covered anywhere across this scale. Our colleague Anton created this chart, and I borrowed it from him as I think it illustrates this concept really, really well. So, on the minimal end, we have AI assistants like code completions. You can use these when you know what you want to build and you know how to write the code. You just want to write it a bit faster. Even within completions, it is a scale. You might want minimal completions for just the next few words, or maybe you want several lines of completion all at once. One of the completions that JetBrains AI Assistant offers that I personally really like is local full-line completions. This is only available in IntelliJ Ultimate, but it's only available in IntelliJ Ultimate, and it includes models that can provide completions for you completely locally. So it works even when you don't have an internet connection, which is great when you're stuck somewhere without Wi-Fi, for example. AI Assistant also has cloud completions, which is available in every IDE, including Android Studio. This supports more languages and can give you more complex suggestions, like multi-line completions. You're probably used to these kinds of AI completions by now. The only thing that I would like to highlight is that you can choose to accept the completions from AI Assistant partially. So instead of accepting everything in the suggestion, you can accept just the next word or the next line of the suggestion, as you can see here. Since you'll see a bunch of demos in the talk, I just want to make a quick note here. I'll be using the KotlinConf app as the project for these, which is the official schedule app for KotlinConf. This is one of our primary samples for Kotlin multi-platform and Compose multi-platform, and it has all sorts of conference-related features that you might expect. So it has a schedule and speaker pages and so on, and you'll see some of these in the demos. Now, back to completions. One of the latest features that we have here is NES. Not this NES, but next edit suggestions. These let the IDE suggest edits for you as you're typing beyond just the regular AI completions. This feature is in beta in 2025.2, so you'll need to enable it in settings to try it. So let's say that I'm editing some code that deals with the dimensions of a map. If I change the numbers in one of these calculations here, we'll see that next edit suggestion will give us the suggestion to change all of the other related numbers the same way. And if I like that, I can accept it by hitting tab. Or similarly, if I go to rename a variable here, for example, to change valid offset x to xrange, it will then suggest that I rename the other similar variable for the y coordinate as well. And again, I can hit tab to jump to that suggestion, and then tab again to actually replace it and accept it. It will then continue offering edits further down the file. So I can jump to these usages of the variables, and then again hitting tab and tab to rename each of them. Of course, for something like renaming a variable and changing all of its usages, we already have IDE actions that can perform this in a single step for you. So if I undo these edits and go to the settings for next edit suggestions, I can enable code insight actions, which means that when I rename a variable manually, next edit suggestions can give me the suggestion to use the built-in refactoring tool of IntelliJ to rename that variable across the entire file. So if I hit tab to accept that, you'll see that all of the different usages of that variable have been updated in just one step. Once this is done, next edit suggestions will of course still suggest further steps like renaming the range for the y coordinates so that it matches what we already have for x. And I can just hit tab to accept all of these. The next step on our scale of AI assistance would be generating some code in the editor by providing a prompt to AI Assistant. This can be useful to generate things like small classes, implementations of methods, and so on. And you can also use it to change existing code that you have selected. For a quick example, let's look at this method where we are downloading new data from the network and then saving it into storage. I want this method to compare the old and the new data, and for any sessions that have been removed in the new one, we need to remove them from a list of favorites and cancel any scheduled notifications. AI Assistant can easily generate this code for us, finding these session IDs that are missing in the new data, and then updating the favorites and canceling notifications, calling into existing methods within this class. While you can enter your own prompts like that anytime, we also have some built-in AI actions for you for frequent tasks. For example, you can easily generate documentation or unit tests using these AI actions. While it's not exactly code generation, I also wanted to mention that you can have AI Assistant generate commit messages for you. The really cool part about this is that you can customize the prompt that's used. So if you have a preferred format for commit messages, whether it's about having a description or not, or some prefixing convention that you might want to use, you can set that up explicitly here, and AI Assistant will follow those instructions. Moving on to the next step on our scale, we have chat-assisted programming. This is the classic interaction mode with AI tools, where you can have a conversation with an AI in a chat window. AI Assistant also offers this feature, and you can ask both general programming questions and questions about your specific project. When you do this, AI Assistant can use any information from your IDE as context to give you the right answer. For example, you can see here that as I'm asking a question about K-Tor best practices, my current file is automatically attached so that its contents can be reviewed. As I send that question in, I'll get some recommendations in a moment, such as adding timeout configuration to my setup, setting up retry capabilities, and improving the logging configuration. I also get the entire suggested configuration as a single snippet here, and I can use the apply button at the top of that code block to actually merge that into my current file and get those changes into my code, like that. Now, when you talk to AI Assistant, you have a wide range of models that you can choose from. This includes local models with options like Ollama or LM Studio, as well as cloud models from providers like Anthropic, Google, and OpenAI. You can manually add attachments to your, you can also add attachments to your messages, such as files or even images for models that support it. So we covered quite a bit of the scale so far. What does it look like to get even more assistance from AI? This is where we get into the territory of AI agents. When using an agent, you give it instructions, and then the agent can execute a task end-to-end, from analyzing it to actually making the changes in the codebase and then verifying them. For tasks like this, we'll use Junie, which is our AI coding agent. Junie is a separate plugin, and it has its own tool window, but it's part of the same JetBrains AI subscription as AI Assistant. So our sample app has a system of feature flags already, as well as an about screen, which has links to various resources within the app. So what I'll do here is I'll open Junie and give it the task of implementing a brand new developer menu screen where I can toggle each of those feature flags on the UI. I've added details to the task here, like the name of the flags manager class that Junie should use, and that I wanted to reuse existing UI components that are already in the project. I'm also asking Junie to add the version number to the about screen and to open the new developer menu screen when that version is tapped 5 times, which is, of course, a classic interaction pattern for Android. I have set Junie to code mode here, which means that it will actually make the edits to the files that are in my project. I also have Brave mode turned on, which allows Junie to run arbitrary command line tasks if it wants to. Without this, Junie would ask for confirmation every time when it's performing a potentially unsafe operation, like working with Git or deleting existing files. So let me actually start this task, and we'll speed this up a bit as Junie is working through it. You can see on the left that Junie first created a plan of how to perform the task. As it's going through that plan, you'll see all of the individual steps that it's taking on the right-hand side. It starts by reading and analyzing files, looking at how feature flags are implemented, how the navigation works in the app, and what UI components are already in there. And once it looked at all of that context, it will actually start writing the new code. So we'll see here in a moment that the new screen is created by Junie, and after that, it will also add the new screen to our navigation setup, and finally add the version number to the About screen and connect that with the click handler and the navigation logic. And now that we're done, we can run the app, and we'll see that the About screen indeed has the new version number. So we can go to the About screen, there's the version number, and tapping it 5 times opens the new developer menu that Junie has implemented. Junie built not just the UI and the navigation here, but also the logic that actually stores those values of the flags using the flags manager. Of course, the results are one thing, but you probably still want to review the code that Junie generated. You can always go through the diffs by looking at the changes in Junie's summary. As you can see, Junie followed all of our detailed instructions, making complex changes to multiple files of the codebase, all working together to achieve the task. It also followed existing patterns in the codebase, like navigation, and even used existing UI components, like that settings item that was already in the project. So that was coding with the help of an AI agent. We had Junie perform a task that we could have also implemented ourselves, but instead of doing it manually, we delegated it to Junie, and then we just reviewed the solution. So what's beyond this step of assistance? That would be the vibe coding level. So this is the scenario where you know what you want to build, but you might not know how to actually write the code. It might even use libraries or APIs or languages that you are not familiar with. The tool here to use is still going to be the same. We'll use Junie again. But instead of giving it precise instructions, we'll try giving it something high level and just see where it takes us. Just remember that this is always a trade-off. If you give Junie more detailed instructions, it will give you better results and complete the task faster. But with vibe coding, the results are going to be less predictable, and it might take more time to complete the task because Junie needs to find all of the relevant context and information for itself. So let's do some vibe coding. One of the great parts about KotlinConf is that there's always a party at the end of the first conference day. Now, the party looks pretty boring there in the schedule. So I'll ask Junie to add a fun animation to it using Kodi. Note that I am not adding any details about how to do this, like which files should be edited or anything like that. I'm just saying add a fun animation with Kodi. So Junie here, as I start it, will inspect the existing codebase, figure out where that party item might be, how the schedule screen works, if there's anything related to Kodi or parties already in the codebase that it might be able to use, and then it will make its edits. And since I'm running the, it will not play my video for me. OK, yes. Since I'm running the desktop app here with Compose Hot Reload, it will actually show me the updated UI instantly as Junie makes the edits to my sources. And we can see that we added a nice little Kodi animation to the party now. Now, when you're vibe coding, you're not always going to get the desired results on the first try, or you might come up with more ideas as you are going along. For example, I think that adding some confetti could really help us with this party animation. So I'll simply ask Junie to add confetti. And as I added this under an existing task as a follow-up prompt, Junie will now have all of the context of the previous task already. So it doesn't need to find things like the party event in the codebase again. All it needs to figure out is how to add the confetti. We actually see Junie making some mistakes here briefly, as it's going to try using some Java math imports. But as it gets feedback from the IDE, it will correct those mistakes, and it will get us back into a compiling state again. And as we get back to that, hot reload should trigger again, and we see the confetti falling on the party event, which is just what I asked for. With that, we are out of time for my demos here, so I'll just quickly show you some highlights of what else you can do with Junie. Starting with project guidelines. You can set up a guidelines.md file in your project, and Junie will automatically use the contents of that file as part of the context for every task that it works on. So you can use this to provide general instructions about your project to Junie. This could be about conventions and dependencies that you prefer using, or you could describe which tests should be executed when certain changes are made, and so on. One of the newer features that Junie supports is MCP, or Model Context Protocol Servers, which is a standard that can expand the capabilities of agents by connecting them to external tools. This means Junie can talk to services as it's working through a task, and you can see that, as an example, I have a handful of servers already added here, like Context7 or GitHub MCP. These are all configured in the common JSON format for MCP configuration, which is the same one that Claude uses. You'll then see MCP calls when Junie decides to use one of these servers as part of running a task. And of course, you can always give it explicit instructions to use MCP for something if you already know that it should use that. Junie also has model selection available in settings. By default, it uses GPT-5, since that became available, but you can customize it to use a different model if you prefer. To wrap up my section, I have to mention one last thing about Junie, and that's that you can also use it on GitHub. This is currently in early access, so you'll need to sign up for the waitlist if you want to try it. Once you have Junie set up for a repository, you can take an issue, like this one, and then just tag Junie to get it to start working on it. You'll see that it reacts with a little thumbs up emoji, and it will also give you a comment telling you that it's working on the issue. Then, once it has a result, you'll see the proposed PR that Junie opened. From there, you can review the PR as normal. You can see the changes, add comments to it, and add any additional comments if you want to. And of course, you can always ask Junie to make further changes to the PR as well. Just remember to always tag it in your comments so that it knows that it should do some work. With that, we have covered the entire wide scale of AI tooling in just about 20 minutes here. So wherever you land on this scale of preference, we hope that you'll find both AI Assistant and Junie useful in your day-to-day work. If you want to learn more about our AI tooling, jb.gg/AI will take you to our landing page where you can find out everything that you might need. And with that, we're ready to wrap up this story and continue with the next one, which is building AI-powered apps in Kotlin.
All right, very good. So we've seen how AI can help you as a developer become more productive. Next, we want to talk about how AI can be used to improve the capabilities of your own applications. With Kotlin, it's possible to do this on any layer where you might need an AI integration. That begins at the lowest level, which means the model provider SDKs. It extends to a core toolkit that is designed for using AI, and it stretches all the way to building your own agentic systems in Kotlin using agentic frameworks. We'll get a brief overview of all these layers, but we'll spend most of our time talking about that last layer, the agentic framework. On the lowest layer, we have the model provider SDKs. These are SDKs that are being provided by the LLM vendors itself. For example, here we have the OpenAI Java, the Java API library. It's very funny because it is designed for use with Java, but our friends at OpenAI have chosen Kotlin to actually design the implementation of it. So we think that's a really great choice. It's not just OpenAI, of course. Anthropic, the makers of Claude models, also provide an SDK. And again, it's designed for use with Java, but again, they have chosen Kotlin for their implementation. It's pretty funny. We're, of course, quite excited about this because it also means that you have a really good experience when you're developing applications using these libraries from Kotlin. Google also provides a wide suite of AI and machine learning-based functionality. And that, of course, also gives you easy access and easy use from Kotlin. MLKit comes to mind here, which allows you to run machine learning workloads on mobile devices without actually having to go through a cloud implementation. And as part of Google's AI Edge, that also extends to running large language models completely on your mobile devices. That works via the MediaPipe SDK. Of course, with on-device tasks, hardware limitations do apply, but it's still very exciting to see these things be able to be done from Kotlin. Okay, so from here, I want to move up the stack and go all the way to agentic AI, because we at JetBrains have developed a framework to build exactly such agentic systems in 100% Kotlin. Let's take a look, and let's start with an introduction to the framework, which is Koog, our Kotlin AI agent framework. So what's Koog? Well, in short, it's a framework that's designed to create agentic AI systems. It's 2025. You probably already have an intuition of what an AI agent is, because it's really something that everybody is talking about these days. But to provide you with a definition, it's a system that uses a large language model as its engine in order to make decisions. Now, of course, they typically don't do this in a clean room. They also need to be able to consume information from their surroundings, and they need to be able to influence other systems, for example, controlling external systems. So where does Koog fit into this? It's a framework that's specifically designed to build exactly these systems. You can build systems that use LLMs to make decisions, but you can do it in a way where you remain in control. Koog manages the interactions between your code and the natural language layer that's used by the LLM, and it also provides you with the most important abstractions that you need to express your workflows. Those are typically shaped like graphs, and like we'll see later, Kotlin's domain-specific languages lend themselves really wonderfully to expressing these in code. Now, since version 0.4, Koog is fully multi-platform, which means that you can build agentic systems that run on Android, on the JVM, on the web, and on iOS. It's important here to note that Koog is the framework for building agentic interactions, but it's not an inference engine. So Koog doesn't do any of the actual inference tasks, which results in the framework being very lightweight. Instead, here you are relying on external APIs to run the LLMs. So Koog really focuses on modeling workflows and providing you integrations that are required to scale your agents. So we'll also briefly look at some of those more advanced use cases in just a little bit, but I'm getting ahead of myself. In my opinion, the best way to understand how our technology works is to just dive in and play with it. So let's cook with Koog. I'll give you some hopefully directly applicable advice that you can use to also explore on your own and start your own Koog journey. Like I mentioned, Koog itself is LLM agnostic, so you can plug in any kind of LLM API that you want. Out of the box, there are some convenient wrappers for Google, OpenAI, Anthropic models, and even integrating with Ollama to run on your own device or on-premise infrastructure. And it provides API access to all kinds of models. If you already have API access to any of them, great, you can plug them in directly. But if not, I have a personal recommendation for you, and that is to use OpenRouter. It's also directly supported by Koog. What makes OpenRouter special is that it's a single entry point for using different LLMs. That includes flagship models like GPT-5 and Gemini, but it also means that you can access hosted instances of smaller API models, smaller LLMs, that run on specialized inference hardware. So they're really, really fast. And the process is also just really easy. After signing up, you buy some credits on the platform, and then you spend them on whatever LLM that you want. You can even just load the equivalent of $5 on there, and you will see that you can make a lot of LLM requests. And because you're buying credits, there's never a scary situation where an AI company might charge you large sums of money on your account. I'm not being sponsored by OpenRouter to say any of this. I just genuinely believe it's the best way if you're experimenting, because it allows you to switch from ChatGPT to Claude to Llama just by switching a single line of configuration. You don't have to set up billing 5 times. It's very useful. Right, you get a lot of tokens. So you can see here that OpenRouter has a wide array of models available for you to use. That includes the latest state-of-the-art models. And sometimes OpenRouter is even the place where AI vendors make new research models available for free under some code names, so you can try them early. It's a really phenomenal thing. Okay, enough about OpenRouter. We only need it as part of our infrastructure to access an LLM. Let's write some Koog code. So we can see here that what a very simple agent looks like in Koog. Well, you just create an AI agent object. We specify an executor, which actually runs the LLM queries. And then we can see that I can just plug in OpenRouter. Then we can specify a system prompt to affect how the model behaves. And we, of course, specify what model to use. Here we use GPT-5 because it's a pretty modern model from OpenAI. The resulting object we get here is an agent of type string to string that makes sense intuitively, I think, because it's an agent that takes natural text and then we can, it doesn't do anything special. So here we can call agent run with a query. I ask, what is the capital of Bavaria? And I get the result as type string, which is as expected. Well, the capital of Bavaria is Munich. It's my hometown. I can recommend visiting if you get the chance. But of course, sending a request and receiving a response is a very, very simple case. In reality, when we build agents and agentic systems, we need much more functionality. Of course, we need to be able to exchange more than one message. We need to be able to do multi-turn conversations. We also need a way to steer the agent, to control its behavior, to make sure that it does the right thing at the right time, that we give it access to whatever is most relevant at the right time in the agentic process, and to make sure that, for example, its output also has the structure that we expect. We also need to be able to integrate it with tools so it can handle other software. For example, it might need to write down a note with persistence, or it might have to send a calendar invitation, transfer some money. All of these things happen deterministically, so you need a way to bridge the worlds of squishy LLMs and hard software tools. Of course, if you plan on rolling out the agent in production environments, you also need to be able to introspect it, to observe it. Because when things go wrong, you need to be able to understand how they go wrong. You need to understand where your agent is spending time, where you're spending tokens so that you can optimize your workflows, and so on. And the good news is that Koog gives you all of that. You get everything that you need to build production-ready agents. So let's get a little bit deeper into it now and examine some of those fundamental structures. At its basic level, you can split an AI agent built with Koog into two parts. The first is the actual conversation that's happening between the user, or an automated stand-in for the user, and the LLM in the role of the helpful assistant. We can think of this part as the data that's being handled by Koog. You typically don't need to interact with the LLM message history directly in Koog. Instead, you rely on the framework to manage it for you. The part that you customize and work with the most in Koog is its graph representation of workflows. You can think of them as an expression of the behavior of the agent. They're state machines that express how you want the agent to behave, what tools you want to give access to. You can have validation cycles and so on. It's very high level. Let's dive a little bit deeper. So, like I mentioned, the LLM message history is automatically managed, so you're not expected to keep track of sent and received messages. Of course, you can still make changes to the history, but you don't need to come up with your own data structures to manage the history during normal operations. The LLM history is also integrated with advanced features like history compression. We'll talk about them in a little bit. When you talk about behavior, the key building block is a node. Like in a flowchart, a node has an input and an output and some behavior attached to it. What are some things that nodes can do? Here's some examples. The node LLM request takes an input string and makes a request to an LLM and then returns us an object of type message response. That can either be a message in the role of an assistant or a message that the LLM would like to execute a tool. The execute tool node takes a tool call request from an LLM, then it runs it, and then it returns us the result of that execution. And the send tool result node takes exactly this kind of result and sends it back to the LLM for evaluation. And we get back whatever the model decides to answer. There's some special nodes like start and finish that indicate the beginning and the end of these kind of workflows or strategies. You can already notice here that nodes are type safe, so they have input and output types. And we will see later in Kotlin, when you express things in code, you get the help of the Kotlin compiler to make sure that everything is constructed as a valid graph. This, by the way, is a real superpower, as some of the other frameworks with dynamically typed languages typically don't have this. So it's probably quite easy to understand that we can just snap together some of these nodes using edges. Here we're doing it simply based on types to receive a well-formed workflow. Of course, these edges can also have conditions, for example, to make them more complex or to allow branching. Besides these built-in nodes, you can also create your own nodes. Their implementation shouldn't be too surprising either. You specify the input and output types as generic parameters to the node function and specify the behavior of the node as a Kotlin lambda. Okay, we have the individual building blocks. What does it look like when we express it in Koog? Let's take a look. A lot of code, don't worry. Here we want to use an agent to classify a user input into 3 emotions that are expressed using emojis. We construct this graph that you can see up here. It takes a string, for example, I am feeling blue. What emotion am I feeling? This should then be sent to the LLM. And if the LLM responds with one of the allowed smileys, then we move to the finish node. And we're done. If the LLM responds with something else, which can be common with the LLMs, non-deterministic, we ask the LLM to only use the smiley, neutral face, and frowny, and then we send it back to the LLM until we get a satisfying solution. For original prompt of blue, we would probably expect a frowny. And below we can see how we actually express this in Koog. In the blue section, we first create all of the nodes. Start and finish exist automatically. We only need an LLM request node as a node that contains the instruction of only use specific emoji. The code for this simply uses regular Kotlin expressions together with the by keyword. Then in the orange section, we're defining the edges, the arrows that go between the different nodes. So from the start, we go to the sending node, then we specify a condition. When the assistant message contains our emojis, we're done. That's what we express using the onAssistant message condition. If it was not the case, then we take the edge to node say emoji, please. As you can see, we have a very straightforward way of expressing the graph in text. And all the nodes stay type safe, so if we make a change that would make the graph invalid, we would get a compiler error. We also didn't touch the LLM history at all here. It was actually fully managed by Koog. These graphs can become arbitrarily complicated. So for learning purposes, I think this graph is enough to give you a good idea of how to assemble things. At the end, what we get here is a strategy, which is the terminology that Koog uses for these kind of workflow-style graphs. Yes, you can make them as complicated. We can plug in this strategy into the definition of our AI agent, like we constructed before, and then it will just use it. That's all there really is to it. Just one line of configuration. So far, our AI agents have still operated in a vacuum. They haven't really affected the outside world, and they haven't consumed information from the outside world. That's already potentially useful, but it gets much more useful when we allow the agent to interact with other systems. There's a standardized way to provide AI agents with deterministic integrations. Those are called tools. And with those, we can give AI agents the power to, for example, read a GitHub issue or transfer some money. LLMs are actually specifically trained for a format that allows calling tools. On OpenRouter, they typically have a specific marker. You can find them at a glance. But the flagship models from large companies, Anthropic or OpenAI, they all have tool calling baked in. By the way, the good part about tooling integrations being deterministic is that you can also add safety checks here. Maybe it sounds scary to say the AI should be able to transfer money, but the application code, instead of just executing the query, it can first prompt the user with a confirmation, for example. So you get a lot of power from being able to specify tools from Kotlin. So how would we declare a tool that, for example, reads a GitHub issue given a repo identifying issue number? Well, if we have a GitHub client, we might do it like this. It's not the entire truth. The reason is large language models operate with natural language, so we need to provide instructions to the model on how to actually fill out all the individual parts of a function call, all the required parameters. It's the same as if you want to teach your colleagues about it. You need to provide documentation. In Koog, you do this via annotations. It's more text on the slide now, but if you look closely, you'll see that the logic of the code is quite unchanged. We've just added descriptions, and for this tool set, that's what we call a group of tools in Koog. And of course, the instructions for the individual parts of our tool as well, the tool itself and its parameters. It's not complex, but it helps the AI model understand what it is able to do. It's just more annotations. So once again, plugging this into our AI agent is very easy. There's just a parameter called tool registry, which takes this as takes a builder. So here we're adding the tools from the GitHub issue toolset, and now we have an agent that can call the tools that we specify. As a bonus note, you can also make tools available conditionally or only at a certain part of your strategy or even in subgraphs. There are a lot of customizations that I encourage you to explore, but given the time constraints, we'll keep it simple. So this integration gives you full control to write your own tools, but of course there's other existing systems that should probably also be integrated. And for this, there's a standardized protocol that is quite popular. It's called MCP, Model Context Protocol, and that allows you to connect with external services. If they're running right on your device, you do this using standard I/O, and if they are remote services, you use a special communication protocol using server-sent events. Both of them are provided out of the box by Koog. If you don't know what kind of services you might be able to integrate using MCP, you can go to a website like MCP Market and find some inspiration in different categories. More and more software and services expose some MCP integrations. And in fact, JetBrains IDEs can also act as MCP servers. So if you want your AI agents to control JetBrains IDEs, read code in open projects, MCP can be used as the communication protocol. Plugging these services in is pretty easy because effectively you're just defining external tools. So you can use the same mechanism that you use for specifying tools you built yourself. It's just a tool registry. The part that changes is how you define the tools. If they're standard I/O, you construct a process to connect to, and then you simply wrap it as part of a registry provider. For server-sent events, it's even simpler. You just specify the URL to connect to, and Koog uses its built-in cater engine then to manage the connection lifecycle. Now you already know a bunch of things about Koog that can make you quite productive, but I also want to show you some of the more advanced cases as well. For example, if you recall, an agent so far was just kind of a function, a complicated one, but from an interface perspective, it takes a string, your prompt, and returns a string, whatever the final message of the LLM was. And if it's just a function, then of course nothing stops you from turning it into a tool itself to use from another agent. So hopefully you can imagine that composing multiple different agents as tools is really cool. Converting an agent into a tool, support out of the box, you just call an extension function and you're done. And by the way, you're also not limited to strategies that take strings and return strings. Kotlin, the Koog strategies have the full power of Kotlin generics and the Kotlin type system. So that means you can define a strategy that takes a string as an input, but returns a number as an output. It can look somewhat like this. We specify the types, and we connect our node to number node, and we get the sum of our input values. When we return it, we need to do a little bit more work. But once again, we can invoke it like a function using run, and we get back the actual return type. In this example, we're not even interfacing with an LLM, to be honest. We're just still using Koog. Okay, for our translators, I will be skipping just 1 or 2 slides, so I hope that you will be able to catch up. Because there's one more topic that I just want to very briefly talk about, and that is history compression. To put this very shortly, LLMs struggle when you provide them with a very long context. If you have short context, everything is fine, but not only does execution get a lot more expensive, the results of your LLMs also get much worse when you have a large context. Koog provides something called history compression to fix this problem. History compression simply allows you to remove specific parts of the context using strategies so that you can keep in the sweet spot where the application works well. Koog supports also a lot of additional advanced use cases, which I invite you to explore. These are topics like memory management with concepts and facts, content moderation, ranked document storage for RAG, and also things like testing and mocking. If you would like to find out more about Koog, we recommend you to visit koog.ai or check out our YouTube channel. And of course, you are more than welcome to find us after the presentation to ask any questions or also see a couple of live demos that we have prepared for you. So, thank you very much for attending our session, and we are ready for questions in the speaker zone later on. Thank you very much.